Good morning to all of the students. Today we will discuss about the work and energy. Yesterday we discussed already on the last lectures about the work, and we have seen about the cos theta. Cos theta means I already told you that you will learn in algebra this year. Algebra or geometry, that adjacent and opposite hypotenuse we are telling. Adjacent and the hypotenuse of the included angle. Now we will discuss about the unit of the work. Work you know as in a force into displacement. Force you know Newton, and displacement means as in a meter in a SI unit. Now in SI unit of the work, as in a Newton unit is there, and unit of the displacement is meter. So we will tell as in a Newton meter, and Newton meter combining we are telling as in a joule, means unit of work is joule. Now 1 joule if you will tell, so 1 joule is what? 1 Newton whatever the object that you will displace as in a 1 meter in the direction. तो amount of work we are telling as in a 1 joule. मीन्स हम लोग बोलेंगे 1 वर्क क्या बोलेंगे, 1 जूल क्या बोलेंगे, जब 1 न्यूटन का वर्क 1 मीटर तक डिस्प्लेस करेंगे तो उसको हम लोग 1 जूल बोलते हैं. तो 1 जूल इज व्हाट? 1 न्यूटन इंटू 1 मीटर. और सिंपल एन एग्जांपल, हाउ मच फोर्स यू अप्लाइंग इंटू 1 मीटर डिस्प्लेसमेंट. फोर्स यू नो वेरी वेल, मीटर इंटू एक्सेलरेशन, मास इंटू एक्सेलरेशन, that mass into acceleration and the meter, the all combining we are telling as in a joule. Means how much force you are applying into 1 meter, that we are telling as in a 1 unit of the work, or we are telling as in a 1 joule. So 1 joule is what? 1 newton into 1 meter. So they given as in a 1 joule is what? 1 newton into 1 meter. This is a SI unit. Now in case of the CGS, in the case of CGS the force is dyne and displacement is centimeter. The force is dyne and displacement is centimeter, and dyne into centimeter we are telling as an erg. Dyne और centimeter मल्टीप्लाई करेंगे तो अपने को erg मिलता है. मीन्स इन CGS सिस्टम ऑफ द वर्क वी आर टेलिंग एज एन यूनिट इज erg. तो here 1 erg we are telling what? 1 dyne centimeter is displacement into 1 meter. Then we are telling as an 1 work, 1 erg. 1 dyne into 1 centimeter displacement of the work is there, then we are telling as an 1 erg. So 1 erg equal to 1 dyne into 1 centimeter. Now relationship between the joule and the work. How the joule and work is displaced, means what is the relation are there. First we will see 1 newton is what? 10 raised to 5 dyne, and 1 meter is 10 raised to 2 centimeter. So work we know that force into displacement. Now you know very well work is what? 1 newton or 1 joule. Unit of work is what? 1 joule. Now force is 1 newton and displacement is 1 meter. Now force, as already you have seen, 1 newton is what? 10 raised to 5 dyne, and displacement is what? 1 meter. So 1 meter is what? 10 raised to 2. So 1 newton place you will put 10 raised to 5 dyne, and 1 meter you will put 10 raised to 2 centimeter. So 10 raised to 5 into 10 raised to 2, that is dyne centimeter. The word dyne centimeter, as already we have seen in CGS, is what? Erg. So 1 joule is what? 10 raised to 7 erg. 10 raised to 7 erg. This is the unit of the work in CGS and SI unit. So in SI unit we are telling as an what? Joule, and in CGS we are telling as an erg. So 1 joule is equal to 10 raised to 7 erg. Now we will see about the positive work, negative work, and the zero work. We will discuss by pushing a stalled vehicle. Whatever the stalled vehicle are there, when you will push, so it will go in the forward direction. But it is possible the single man push can the vehicle. The single man can push a vehicle. It depends on the vehicle, which kind of the vehicle are there. That is a 2-wheeler, 4-wheeler, truck. This depends. If 2-wheeler vehicle are there, the single man can easily push it. But in the case of the car, the person has to apply more and more force. It depends. It depends how much force we can say, what quantity of the, what magnitude of the car are there. We can say what quantity of the car are there, or what quantity of the vehicles are there. Now the catching the ball which your friend has thrown towards you. Now when your friend are throwing the ball towards you, you know when you are playing in the open ground, you are doing the catching, throwing the ball one into the another one. The ball, the friend that threw the ball to in the you, that you are according to you, in your friend, you are in the opposite direction of your friend. Means the ball is coming from opposite direction to you. tying a stone to one end of a string and swinging it round and round by the other end of the string. You know, in day-to-day life you are playing, the small kind of the children are playing. The children are tying a string, we can say they are taking a string and tying in the opposite end. At the last end of the, we can say they are tying a stone and then swinging, means round into round, round into round, round into round. Now it depends on the string. String is what kind of the string. The string can be a, we can say, a thread string are there or rubber string are there. Now walking up and down staircase, climbing a tree. When you are going up and down to the staircase, you know, first you are going up and then coming to the down, सीढ़ी पे चढ़ते हो, फिर नीचे उतरते हो, फिर climbing a tree. When you are going up to the tree, झाड़ पे चढ़ने का काम होता है. Stopping a moving vehicle, car, by applying brakes. When you apply a brakes, whatever the cars, it moves. And suddenly when you are applying the the brakes, what you observe, the car directly doesn't stop. The car directly doesn't stop. It moves in the forward direction for some meter and then it will stop. First we have to what you have to do, you have to slow the speed and then you have to apply the brake. Otherwise what you will observe, the body will come directly in the forward directions. Now you will notice in some of the above example, in all this example you will see the force and displacement are there. Pushing a stalled vehicle, you have to apply a force, and how much displacement means how much force you will apply, so the vehicle will move in the how much, it is in a 1 meter or something half meter. So force and displacement, they are all in the same directions. But in the other case you will observe, as example, catching the ball, the persons are throwing the ball in front of you, that is in the opposite directions. While in some other case you will observe they are in the perpendicular to each other, means standing. As example of the walking up and down a staircase, tying a stone, you will observe the stone is tying in the horizontal direction, we can say perpendicular directions. That we are telling as an example of the perpendicular one. In this case is the work done by the following example. Now all the 5 example you will see, that is positive work, negative work or zero work. So we will discuss about how when the force and displacement are in the same directions. When the force and displacement are in the same directions, then we are telling as the work done is a positive. The work done is a positive. As example, pushing a stalled vehicle. The vehicle you are pushing in the forward directions. सामने एक ही डायरेक्शन में, मतलब तुम धक्का मार रहे हो तो गाड़ी भी सामने ही जा रही है, तो एक ही डायरेक्शन में, that we are telling as what, forward direction, that is positive work. But when it is an example of the opposite directions, the displacement are in the opposite directions. As example of the second, catching the ball. When your friend thrown towards you, जब बॉल थ्रो कर रहा है तुम्हारा फ्रेंड तुम्हारे सामने, तो ये ऑपोजिट डायरेक्शन का है, तो ये नेगेटिव वर्क होगा. दिस वी आर टेलिंग एज नेगेटिव वर्क एग्जांपल्स. तो whenever the opposite direction works are there, then we are telling as negative. The opposite direction is what, theta equal to 180 degree. But in the case of the positive direction, theta equal to 0 degree. जब 0 डिग्री का वर्क है तो समझ जाने का पॉजिटिव, एंड दैट इज 180 डिग्री मीन्स वी आर टेलिंग एज व्हाट, नेगेटिव डायरेक्शंस, ऑपोजिट ऑफ यू. But in the few of the cases, look, when the applied force does not cause any displacement, the displacement is not possible. The displacement is not possible. तुम कितना भी फोर्स क्यों ना अप्लाई करो, सामने वाली चीज़ हिलने वाली नहीं है. As example, when you will push the wall, अगर तुम वॉल को धक्का मारोगे, दीवार को धक्का मार रहे हो, तो पॉसिबल है कि दीवार आगे जाने वाली है. When we can say no, you are applying the force. तुम्हारा वर्क क्या हो रहा है, इधर जीरो हो रहा है. That is zero work we are telling, this kind of the things. So when the perpendicular works are there, that theta equal to 90 degree, so on that time we are telling work done is zero. We are telling as work done is zero. Now just see few of the examples. Try this activity. They are given 3 tables. Table A, Figure B, Figure C. In the case of Figure E, you will see the cup is there. In the cup, the stone is there. They put it a hole. Just see, take a plastic cup, make a hole. They are telling you at the center of the bottom, and the long thread and a double thread they are telling, and keep it in the hole. Just put in the hole here. You will observe. Tie a thick enough knot at the end. एकदम thick, पतन धागा बांध देने का तरह का. What you will observe, so that the knot will not pass through the hole. इस तरह से बांधना है कि होल के थ्रू बोलते हैं ना वो धागा नीचे ले जाए. नाउ टाई अ नट टू दी ऑपोजिट एंड. देखो एक नट बांधा है, पहले तो एक थ्रेड लिया है, एक होल है अंदर. फर्स्ट इन द कप दे पुटेड अ होल. फर्स्ट इन द कप दे पुटेड अ होल. यू विल ऑब्जर्व देयर. तो यहाँ पे क्या किया, नट किया और ऑपोजिट एंड में क्या बांधा है, नट बांधा है इसने. नाउ फिगर ए, व्हाट यू विल ऑब्जर्व, पुट द कप ऑन अ टेबल. फर्स्ट सी फिगर इन द केस दे पुटेड अ टेबल एंड ऑन द कीप ऑन द नट्स. बोलते हैं एक नट बांध देना उसके ऊपर फर्स्ट. एंड लेट द थ्रेड कैरिंग ऑन द अदर एंड. दूसरे जगह पे थ्रेड है, थ्रेड के एंड पे क्या है, नट है. यू विल ऑब्जर्व कैरिंग द अदर नट. हैंग डाउन, जस्ट हैंग इट. व्हाट यू विल ऑब्जर्व, स्लोली स्लोली इट विल पुश. क्या होगा, धीरे धीरे करके क्या होगा, जो कप रहेगा ना वो नीचे आएगा. क्योंकि डिपेंड, अब नट का वेट कितना है और कितना ग्लास का वेट कितना है, बट डिपेंडिंग ऑन द थ्रेड टाइप, हाउ मच लॉन्ग थ्रेड इज देयर ऑल्सो. What will happen? What you will observe, slowly slowly it will come down. Now you will observe the nut and the cup, they are coming in the same direction. They are coming in the same direction. This kind of the figure A we are telling as a positive verb. But in the case of the B, you will observe the cup is there, they put it a stick sliding on the table. You will observe, stop it in a ruler. एक कप डाला है, बीच में क्या पुट कर दिया उसने, रूलर पुट कर दिया है in the path. Now what you will observe, the cup will come in the forward direction, but because of the ruler the cup will stop it there, or with the ruler also it will move forward depending on the weight of the nut, remember. And now the figure C, you will just see, keep the nut in the center of the table and leave the two nuts. Now just in both the opposite direction, just hang the nuts. In the figure C you will observe in both the opposite end, you will observe they are hanging the nuts. Now the cup is in the center direction only, so here no work is done. In the figure C you will observe there is no work. So just give the question mark. You will see the positive, negative and the zero work. So they are giving a question A. Figure A, why does the cup get pulled? क्यों pulled हो रहा है? Second, what is the relation between the displacement of the cup and the force applied? What kind of the displacement are there? Force and displacement, they are telling us in a work done, some kind of the. And the figure C you will observe, why doesn't the cup doesn't get displaced? Cup क्यों नहीं हिल रहा है? You will observe on both the end. So in both the end A, B, C, you will see the relationship between the force and the displacement. This all we are telling is in a day-to-day life example. So we will discuss on the next lecture this thing. And just complete the notes of the first chapter that I sent.